Hello, everybody. Welcome to Coding Basics for juniors. There are Coding Basics badges for all levels, but we are going to do the juniors badge today from Girl Scouts of Eastern Washington, Northern Idaho. So let's go ahead and take a look at what the requirements for this badge are. So here's the badge. So step one is going to be to create an algorithm for a computer that follows a sequence. Step two is going to be use loops to improve your algorithms. We're going to talk about what makes a good algorithm. Step three is to keep your code interesting with conditionals. So we'll talk about what conditionals are. And then you guys are going to, step four, write your own set of commands that use conditionals. And then step five is going to be a small research project on learning about women in computer science. So let's go ahead and take a closer look at step one. All right, so an algorithm is essentially a set of directions. So usually the sequence of those directions is important. So I have an example from CodeSpark, which is a free trial that you can have, and there's also a 50% off discount for Girl Scout members. So that's one program that we were going to look at today. So I have an example of what a sequence is and why it's important. So basically, a sequence is the order of things. So when you're giving directions, the order is important. For example, I wouldn't want to put peanut butter on my bread unless I've already taken the bread out of the bag. So step one would be to take the bread out of the bag. Step two would be to put peanut butter on it. Other ways, I want to be smearing peanut butter all over the bag, and that's going to be gross. So the sequence is the order. The algorithm is the total set of instructions. So a computer, you have to understand, is super literal. So what I have here is I have Amelia Bedelia, which is one of my favorite kids' books. And we're going to go ahead and take a quick look at some of the mistakes Amelia Bedelia makes. Now, Amelia Bedelia is the computer in this situation. She is so literal, she's going to follow directions as they're given to her. So if there is a mistake in your computer program, it's not the computer's fault. It's all about the directions you're giving it. So you need to look really closely at your code and look and see what directions am I giving it and how is it not interpreting those instructions properly and how can I fix my instructions. You can't fix the computer. You're not going to be able to fix Amelia Bedelia. She's just who she is. So let's go ahead and take a quick look at Amelia Bedelia. We're going to skip ahead.
Change the towels in the green bathroom. Amelia Bedelia found the green bathroom. Those towels are very nice. Why change them, she thought. Then Amelia Bedelia remembered what Mrs. Rogers had said. She must do what the list told her. Well, all right, said Amelia Bedelia. Amelia Bedelia got some scissors. She snipped a little here and a little there, and she changed those towels. There, said Amelia Bedelia. She looked at her list again. Dust the furniture. Did you ever hear tell of such a silly thing? At my house, we undust the furniture. But to each his own way. Amelia Bedelia took one last look at the bathroom. She saw a big box with the words, dusting powder, on it. Well, look at that. A special powder to dust with, exclaimed Amelia Bedelia. So Amelia Bedelia dusted the furniture. That should be dusty enough. My, how nice it smells. Draw the drapes when the sun comes in.
Okay, so Amelia Bedelia continues to make mistakes. As you can probably guess, changing the towels did not actually mean take a towel and change it up with scissors. But that's what Amelia Bedelia interpreted it as. And then dusting the furniture meant to take off the dust and get rid of it out of the house. But she decided dusting meant to put dust on something. So she is really literal, and your computer is too. So that's why we kind of watched Amelia Bedelia there. Let's go ahead and take a look at Scratch, which is one of the programs that I have here for you to experiment with as you're doing your Coding Basics badge. The other program, as I mentioned, is CodeSpark, and so I have an example of an algorithm in there and talking about why sequencing is so important. Okay, so in this algorithm, we have 1, 2, 3, 4, 5 steps, but unfortunately, there doesn't really matter what order because all 5 of the steps are the same. So the sequence in this does not matter. It's a 5-step algorithm, and we could change any of the steps, the order, the sequence doesn't matter. In this algorithm, we do need to change our steps. So if we need to jump first, and then we're going to need to walk once, twice. And then we'll need to jump again. And then we'll need to walk once, twice, and then jump time. If we change the order at all, that would make the algorithm not work to what we needed to do. If we jumped first and then walked, we would hit one of these crates and it wouldn't work. So the sequence in this one was important and it had to be in the correct order or sequence to win. All right, so this is Scratch, and as you can see, I have a little bit of a code here. Scratch is a program where you can drag your code in, so it's a block programming coding site, and it is totally free, so anybody can use it. You do not have to pay for it. So unlike CodeSpark over here, where you do have a free trial that only lasts 7 days, and then you have to pay for it, and even though Girl Scouts have a discount, sometimes it's nice to just be able to have something that you can practice on that's totally free if you can't finish the badge in 7 days. So what I have here, I'm just going to go over it a little bit. So this is my algorithm right here. So I'm going to click it a little bit. So the first step I have is this is Scratch. You can change your character, and that's down here. So this is the choose a sprite button. So right now I have Scratch, which is this guy. Then I have this set of drums, and they have their own code. So I'm going to show you both of these 2 codes that I made. So the first code for Scratch is he's going to move 30 steps. And for Scratch, positive is this way. So Scratch is going to move this way 30 steps. He's going to wait a second. Then he's going to turn. And I can show you what a turn looks like. So if you ever are like, I don't know what this does, I don't want to put it in my program, you can grab a block and you can click on it. So that's what it looks like when Scratch turns 15 degrees. And this is what it looks like when he turns the opposite. So he's going to do that. I'm going to wait a second in between each one so you can see it a little bit more clearly. And then he's going to do it again. And then I'm going to have him move back 30 steps. So the negative here in the 30 is going to be backwards. So we said this was positive, so negative is backwards. So the other code I have, so this is my sequence, and that's my algorithm. So this is going to be my dance algorithm. So the whole thing is the algorithm, and the sequence is the order it's in. For my drums, I have a whole bunch of different sounds. So I've got play this sound, then this sound, then 3 this sound, then play the first sound again, play the second sound again, play these 3 again, and then end it in a special way. So you'll notice that most of these have this orange thing here. That's called an event. We're going to talk about that in a second. But basically it means when I click this green flag, all of my programs are going to go because both of them are set to go when the green flag is clicked. So let's go ahead and see what happens when I do that. So I just made Scratch do a little dance. So that's what you're going to do. You can find all of your motion blocks, again, up here in motion. All motion blocks are blue. So you can go ahead and just stick to the first 3. If you want to play around with some of these, they just get a little bit more complicated, but they also give you a lot more room to be really exact. And they also help you if you want to make a game later on. So, and then the sound blocks are here. So right now I'm clicked on Scratch. So the only sound I can see in the drop-down menu is meow. That's why I imported these drums, because in the drum menu, play sound, I have 4 different sounds. And if I want to, I can record a sound. So that's kind of fun too. So what you're going to do for your first step of this badge is you are going to either build Scratch a dancing algorithm, or you can go to CodeSpark, and once you log in, which takes some time, you're going to play at least 5 levels of Donut Detective. So that's going to be step 1 for you, is to go check out Scratch at this link, or get on to CodeSpark and play 5 levels of Donut Detective. All right, let's go ahead and take a look at step 2, which involves loops. Now, a loop is a way to make your algorithm a little bit more efficient. So efficient just means that it works a little bit better, a little bit faster, and a little less confusing. So a loop is something that lets you kind of say, oh, I did this a whole bunch. Let me just say, do this 5 times instead of listing it out all 5 times. So a loop gives you a little bit of a shortcut. So I included this here because if you guys have ever read the back of the shampoo bottle, which is fascinating reading, let me tell you, usually it says, go ahead and add your shampoo, lather, rinse, and then repeat as needed. So repeat just means they didn't want to say add shampoo, lather, and rinse, and then add shampoo, lather, and rinse, and then add shampoo, lather, and rinse. They just wanted to say, hey, keep doing it until you feel like your hair is clean. So this would be a loop. And I like this because it really shows kind of the direction of the loop. This would be an infinite loop, except for the fact that they said as needed. So that basically says that at the end of that loop, they're going to check, is my hair still dirty? Then do the loop again. If my hair is not still dirty, then I can just stop. So there is kind of an implied ending to this loop. One thing that programmers can get into trouble with is if they don't have a way to get out of the loop, the computer, just like Amelia Bedelia, is going to follow instructions to the letter. So it's going to keep doing this. If you told a computer to add shampoo, lather, rinse, repeat, it's going to do it forever, until you cancel the program, stop the program, or restart the computer or something. So you have to give it a way to stop. So usually what we do is we say repeat a certain number of times. So this is a fun example of a handshake. So I found this clip from the Parent Trap, which is kind of like one of these handshakes. So this one is where you repeat it. So let's go ahead and watch Lindsay Lohan's handshake. So we could have written an algorithm about her handshake. So first they shook hands, then they started to do this, and then they did some other stuff. You know, I don't remember. But if anything was repeated, we could have shortened the instructions by adding a loop. So that's what this is. I'm going to go ahead and show you this handshake with my dog. But for right now, we're just going to talk our way through it. So we're repeating this twice. So what we're going to do is we're going to do a high five, then a fist bump, then a low five, and then it says repeat twice. So we can't be done with our handshake until we've gone back through again. So then we high five, fist bump, and low five one more time. And then we're done because it said only repeat 2 times. So luckily we don't have to do it forever. So what I want to challenge you to do is to create your own handshake, and it needs to incorporate one loop, one repeat of something. So when you're doing your loop, think about, do I want to high five twice? Do I want to like turn around in the middle? So anything that you're doing multiple times, you're going to go ahead and create a loop for. So this is kind of our example handshake.
Scratch behind the ears, scratch behind the ears. 1, 2, 3. John, you don't know how to shake. You want to try it again? Okay, our special handshake. Eli, you ready? 1, 2, 3. Scratch this ear, and 1, 2, 3. That was it.
So that's what you're going to do. So what we've talked about right now is it efficient? Just means do I have it written down in the least number of steps? So for example, this one, I could have written, instead of repeat 2 times, that's 1, high five, fist bump, low five. So this has 1, 2, 3, 4 steps to it. But I could have written high five, fist bump, low five, high five, fist bump, low five. So that's 6 steps. So a 4-step algorithm, which is what we have here, is more efficient. It's faster. It's simpler than a 6-step algorithm. So that's going to be how you can tell if you're efficient or not. If you're going to be playing with CodeSpark The number of stars typically will help you know if you have finished the game, but also if you've used an efficient enough algorithm, so it'll grade you a little bit on that. So a loop we've talked about is something that shows a repeat. So we've got this repeat, this repeat. A nested loop is when you have a repeat section inside of a repeat section. So I'll go ahead and give you an example of that in Scratch. So let's go ahead and take a look at that. So over here where I have my drum code, what I'm going to do is I'm going to figure out what repeats in this drum code. And then over here in control, I've got repeats. And anytime you see a number like this, you can change it. So I can always delete this and change it to 5 or 50 or whatever I want. So what do I need to repeat? So I said that it plays this sound, and then this sound 3 times. And then it does it again, high tabla, high tin tabla, and then that sound 3 times. So what I can do is I can take, those are the 2 things that are exactly the same. So I can say, grab this, put it inside there, and then I can throw all of this away to the side. And I want to repeat that 2 times in order for it to be the same. Then I just put this at the bottom. So that uses 1 loop to make my code simpler. I just ditched all of that extra stuff. So this is actually shorter than it was. The computer likes this. It can follow this instruction really efficiently. But we can make it better. So I can nest another repeat loop here. Right here, I can say, I want to play this low gliss tabla sound. Oops. It's attached, so attach it. Get rid of that, get rid of that. I don't want to play it 10 times though, I want to play it 3 times. So what's going to happen when this algorithm runs is when the flag is clicked, it's going to see repeat twice. So the computer's going to know, I need to count this twice. It's going to play this sound, and then it sees another repeat. So it's going to be like, okay, whatever's inside this, I'm going to play 3 times. So it's going to go 1, 2, and then this once, twice, 3 times, and then it's going to come back and come back in here. So that's going to be a repeat loop with a nested repeat. So this is a nested loop inside of a loop. So we can go ahead and hit the flag, and it should be exactly the same as it was before. One thing that's cool about loops is I can make this go on forever. Now we talked about if I make something happen forever, the computer really is going to play it forever. What I can do to Scratch is I can make him also dance forever. So the one thing that this program has built in is this stop sign. Usually if your computer is doing something you don't want it to do, the escape key is super helpful. And if you really, really don't like what it's doing, you can push the power key for a really long time and the computer stops, right? So that's the same thing here. The stop button is going to stop this. So when I hit flag, it's just going to keep going forever until I hit this. Okay, so that's loops and nested loops. So your challenge is going to be to go ahead and you are going to add a loop or use a loop to improve your dance algorithm. So if nothing in your dance algorithm actually repeated, this is a really good chance to add a loop and create a repeat, just like I did making it go on forever. But challenge yourself to do something a little bit more difficult. And so that's going to be your assignment in Scratch. If you're doing Code Spark, there's a game called Tool Trouble, and you're going to play 8 levels of that to get your head into loops. Now, the one thing that I have a problem with Code Spark is it does not let you nest loops, which I think is annoying. So go ahead and see if you can, if you're using Scratch, nest a loop inside of another loop. And then remember, you're also going to make your own unique handshake and try to draw it out just like this. So where's the loop? What's happening?
More times, but for now, I think
so that is step 2.
Boxes.
One thing I like about Code Spark is it gives you an example. It shows you exactly what's playing. So when you do a loop, you can see how it's going back around to start it again, which you can't see very easily in Scratch. So I'm going to go ahead and show you what that looks like in Tool Trouble. And then at the end, after we build 1, 2, 3, we're going to need to jump off to get the tool here. So notice how that's outside of my repeat. So that's not going to happen every time. It's only going to happen after I finish doing this 3 times. That was the first time. Notice how this went all the way back to the beginning in order to send me through again. So that was once, twice. Now I'm on my 3rd time. It won't repeat after this. It'll start going straight into this. So the computer will count it for us. So there's a celebratory jump and then he's done. All right, steps 3 and 4 are all about conditional statements. So we're going to talk about one type of conditional, and it's called an event. And that's already something I've shown you in Scratch. It's when you click the flag, something will happen. So the event is a when statement. So when this happens. So I have 2 examples here. We're going to talk about rock, paper, scissors as both an event and an if-else statement. And we're going to talk about traffic lights. So traffic lights, go ahead and think about like what happens when, hear that magic word when, that's your event, when the light is green, obviously you go. When the light is red, obviously you stop. And when the light is yellow, you slow down and expect to stop. Or some people speed up really fast if they think they're gonna make the light, but you don't wanna be one of those unsafe people. So there are 3 different events that can happen with a light. But what's interesting is if we think about it as an if-else statement, and if-else just means if the light is green, then you should go. If the light is red, then you should stop. So it kind of gives you all of the different situations at once instead of making you have a different event list here, here, and here. If-else means if it's this, then this. Now, else is just another word for otherwise, but I don't know if you've noticed, but programmers are a little bit lazy. They like to be super efficient, and the word else only has 4 letters, and the word otherwise has 9 letters. So else is shorter, and when you're typing out code, instead of using block code, it'll save you some time. So they use else. So if we look at this light example, we could have 3 different events for when. When the light's green, when the light's red, when the light's yellow. But sometimes traffic lights aren't actually any of those things. So in some countries, in some places, they actually have a yellow-red light. I've never seen that before, but that's totally a possibility. Sometimes the light is broken and it's not on at all. We should have some sort of event happening for that. And if the light is blinking, yellow, green, or red, then something else might need to happen. So there are lots of things that we didn't cover when we were talking about our 3 events. That's when else statements are really handy. So if I was doing an if-else statement for this, go ahead and take a look up here. If the light is green, then go. Otherwise, if the light is yellow, then you should slow down. That would be one thing. But that doesn't cover all of our situations. So if we wanted to change this, we could say if the light is green, then go. Otherwise, if the light is red, then stop. So the cool thing about an else is we could just say if the light is not green, stop. And then we would have to make another if statement for yellow. So we can squeeze more stuff in here. For rock, paper, scissors, it's kind of the same thing. We need to have a lot of different events covered. So if, let's say I playing rock, paper, scissors. I like scissors. So if I played scissors, then we need to have 3 different situations for what you played. So if you played paper, I win. If you play rock, I lose. And otherwise, it's a tie and we should play again. And that's when a loop could be handy because then we'll repeat those steps. So if else is something that the computer uses to check to see if something's true. Did they play paper? Did they play rock? Or did something else happen? Is the light green? Is the light yellow? If not, then you should stop. Okay, so that's how if else works. So in Scratch, we're going to go ahead and add an event as well as an if else block to our dance. And if you are not using Scratch, that's okay. You're going to go ahead and use this game, Play Puppy Problems. Puppy Problems is the name of the game. Levels 1 through 8, and then you're also going to challenge yourself to Lunch Crunch levels 1 through 10. Puppy Problems is going to talk to you about events. So I've got an example of what an event looks like in that game. And then Lunch Crunch is going to have an if this or if this. They don't do a super great job of else statements. They're both kind of ifs. But Scratch will let us kind of say otherwise. So let's go ahead and take a quick look at Scratch, and then we'll come back and look at these two games in Spark. So let's go ahead and just take a quick look at an if-then block. So this if is going to be, I'm going to change this out. So whenever the flag is clicked, it's going to check to see if this is true. And then it's going to move into the dance. So if, and so what we can go ahead and we can look at is sensing. So this is going to be like if any of these things are happening. So we can say if Scratch is touching the mouse pointer. So we could drag that in, or we can say if Scratch is touching the edge of the screen, or if Scratch is touching the drums, then something should happen. So let's see if we can get Scratch to touch the drums. I'm going to grab Scratch and move him a little bit closer to the drums so that this will actually happen. So what we can say is, let's have him play this sound. Okay. Yeah. I think this will work. It kills me. All right, so when the flag is clicked, we're gonna have the computer check to see if he's touching the drums, then play a sound, while also at the same time playing this dance routine. So if we click the flag, when he moved 30 steps, he touched the drums, so we heard the meow sound. But I only told the computer to check once. So let's see what happens if we try to put a loop on this. So let's forever check to see. And we'll bring Scratch back a little bit. He's a little sideways, but we'll see what happens. So now, since he's constantly touching this drum, he's going to constantly meow. So that's one way you can use an if he's touching the drums. All right, so let's talk about else. So if something, otherwise something else. So let's say if Scratch is gonna be, let's sense something. If Scratch is touching the drums, we'll go ahead and have him meow once instead of meowing all the time. Otherwise, we're going to have Scratch switch costume. So Scratch has two costumes. You can go ahead and check them out, which are down here. So if you click on Scratch, you can actually, it's up here. you can check out, he's got costume 1 and costume 2, so you can kind of see that he might like change positions. So if we go over here, I'm going to put a repeat on this, and I'm going to also put in some wait time so that we can see that he's switching costume. And then I'm just going to have him constantly switch from, I'm actually going to use next costume. So it's just going to have him constantly switch from the first one to the next one and then back again. Okay, so let's go ahead and take a look at this. So if he's touching the drums, but if he's not touching the drums, and notice how since he wasn't touching the drums, he didn't get a meow. And no, we didn't get a repeat on that. So what we can do is we can go ahead and go into our control, and we can loop forever around this. And so then if he's touching the drums, we know what's going to happen. Constantly. And if he's not touching the drums, he's going to change his costume over. And then if he's touching the drums, he'll start meow. If he's not touching the drums, he won't. So that's an example of an if. So if he's touching the drums, otherwise, no matter where else he is, if you're halfway over here, he's just going to keep there. But only when he's touching the drums, he's going to meow. So that's how you can do an if else. You can also do one for your drums, or you can add other characters. Adding characters is here, adding backdrops is here. So you can kind of get a little bit creative with Scratch with this one. The other thing you can do with Scratch is you can go to this event. So we already are familiar with when the flag is clicked, but we can also control what happens when certain keys are pressed. And this is how you start designing a game. So this is a little bit advanced, but I think you can handle it. So if you want to press the up arrow, what you can do is you can have Scratch actually move up on your screen. So you can actually kind of steer him around, which is kind of fun. So what you can do is you can change his direction. So if you think about your screen, up is going to be the Y direction, and this way is the X direction. And if it's down, it's negative, and if it's this way, it's also negative. So you've got Y and negative Y, X and negative X. So I can say change Y by 10. And then I can do the same thing when the right arrow, I can go back here and I can change X by 10. Now 10 is kind of small. We're not going to see that. So I'm going to go ahead and put 50. Ooh, 500 is too big. And 50. So if I click my flag, the program runs. We already know what happens. But if I click the up arrow, oh, I was programming the drum. Now the drums can move around my screen. And they'll just go away. I didn't plan what happens when the left key is placed. So now I just have to drag those suckers back in here. And you can see they're just going to keep going whatever I tell them. The other thing you can do is if you don't like these commands, if you don't want to make a game for events, you can play around with what happens when you click on your character. So you can have your character say hello. So if I click on the drums, they'll say hello because I'm still programming the drum. If I want to go back to programming Scratch, I can go ahead and do the same thing. So I can pull an event over when this, right, and anything that you put on your screen. Okay, so right. When it's clicked, what we want to have it do is we want to have him say.
So this is saying when I hit something.
So when I click on the drums, hello.
So
and when I click on Sprite,
here we're going to need to move
so
up.
those are all events. And then if else's
I
is
can't go
if.
forward. So this is telling me to always go right.
Those are if
So the
statements.
when is
Else
actually
means if it's not happening.
This
And then when means that when I click, something happens. Okay? So those are conditional statements, and you can use them in your code, and it makes things kind of fun. Let's start. So in this level, this is going to be two different if statements. So if they want spaghetti, we'll make them spaghetti. If they want ice cream, we'll make them ice cream. So here in the option menu, we are going to drag an if block. And so over here we have if block. So we're going to drag if block. If they want spaghetti, then we are going to make them spaghetti, which is this side. And then we're going to send it to them. So otherwise, if you want ice cream, and I want to send it to them here, because otherwise if it doesn't live in there, it's going to repeat every time. So this one, if they want ice cream, we give them ice cream, and then we send it to them. I could have made this code more efficient because both of these have a send. So I could have had them send it at the end. That would have made it more efficient, and then I would have been able to skip 2 steps and just have 1 step. So as each customer comes through, the computer's checking. If yes, it's going to do this. But if no, like here, it's going to turn red for no, it totally skips it. So yes, it'll run everything inside. And then it's still going to check this for no. Okay. If the first one's no, it's going to check the second one for yes. If they're both no, I don't know what happened. It didn't give us that option. All right, so step 5, as you hopefully remember, is women in computer science. So you're going to pick a computer scientist to learn more about. You're going to write a mini report or make a 2-minute video about her answering these questions. What are her accomplishments? What challenges did she face? And what do you like most about her? So we have 2 really famous women. Ada Lovelace is one of the first programmers ever. And Margaret Hamilton wrote this code for Apollo 11. Or you can go ahead and research anyone else. There are tons of women computer scientists to choose from, so you can pick one that you really like. So go ahead and finish that up, and once you're done with that, you will have completed your badge. So congratulations and good work. And you can check out more coding in the Coding for Good set of badges. This is the first step, and then you can kind of look at some other things. So maybe we'll revisit these today. Thanks for watching.